So in this video I'm going to discuss the quick sort problem which occurred in today's CODEFORCES challenge. It states that you will given two numbers. This is n and this is k. N is the number of elements in the array. What is in this array? 1, 2, 3. Okay, so you can take k elements at a time and sort them and append it to the end of the array, and finally you have to make the total array sorted. So in this case 1, 2, 3, this is already sorted, so the minimum number of operations needed is 0 because it is already sorted. For this 3, 1, 2, so k is 1, so we can take any one element and sort it and append it at the end, right? So we can take 3 and then 3 is already sorted. Like if you sort like only one element, in that case it is already sorted, right? So you take 3 and you append it at the end, so it becomes 1, 2 and appended 3, that is it is sorted. So one operation. In this case 1, 3, 2, 4, you can take two elements at a time. So what we are going to do is we are going to take 3 and 4. So 1 and 2 is there, and we are taking 3 and 4 out of the array and we are sorting it, that is it becomes 3, 4. Okay, 3, 4, and then we are appending it. So 1, 2, 3, 4, it is sorted. So it needed one operation. 2, 3, 1, 4. In this case, first of all we are going to take 2 and 1. Okay, 2 and 1, and after sorting it 3, 4. Okay, 3, 4 is left, and 2 and 1, after sorting it becomes 1, 2, and we have to append it. So it is 3, 4, 1, 2, and then we are going to take 3, 4 and 1, 2 is left, and we are going to sort 3, 4, it becomes 3, 4, now 3, 4, now it is done. Okay, so we needed two operations, so in this case 2. Now the main logic behind this is you have to find the first position of 1, occurrence of 1. Okay, let that be position, let that be 1. Okay, let that 1 pause. Okay, one position of 1. So how will we find this? We will run a loop from I is equals to 0 to I less than n. If AR of I is equals to 1, then 1 pause is equals to I, and we break it, right? We break it. And once we are done with this, you have to find how many elements after the occurrence of 1, starting from that occurrence of 1, how many elements are there in sequence, in a sequential manner. Okay, so that is, we are running another loop. So let's say count. Okay, count is equals to 1 because 1 is already considered. So count is equals to 1. Then we have to run a loop from position plus 1 to n. Okay, after count, let's say let's a number. Okay, num is equals to 1, that is the previous number. Okay, num is equals to 1, and then we run this loop, and if ARR of I is equal to this num plus 1. Okay, so that is the previous number plus 1, that is in this case, in that position it is maintaining the sequence. Okay, so count plus plus, and the previous number gets overwritten as plus plus. Okay, number plus plus, it gets overwritten. And once we are done with this, so now we are going to do is, let's say int result. Okay, result is equals to n minus count by k seal. Okay, seal, n minus count by k. Okay, this is the whole thing, seal or math.seal of the whole thing, or if you are Java coder, math.seal. So then print result. Okay, so this is the basic thing. So that is, you have to find the number of elements that is in sequence, including 1. So 1, 2, 3, it is in sequence. So 3 minus 3 is 0, and 0 by 2 is 0, so 0. Now 3, see 1, 2, 1, 2 is in sequence, so 2 are in sequence. So 3 minus 2 is 1, and 1 by what was k? 1. 1 by 1 is 1, right? So answer is 1. So 1, 2, right? 1, 2. So two numbers are in sequence. So 4 minus 2 is 2, and 2 by 2 is 1. So answer is 1. In this case 1, Nothing, only 1 is there. Okay, so 1. So 4 minus 1 is 3, and 3 by 2 is 3 by 2 seal. Okay, so in this case, because it is seal, so if it is greater than that number, so we round it off. Okay, so 2, that is 2, that is 3 by 2 mat dot seal of 3 by 2 is 2. Okay, so 2. So this is the basic code. This is the pseudo code. That's it. Thank you.